Hello, my name is Andy Lazur. I'm a water quality specialist with University of Maryland Extension. And I'd like to discuss with you issues with microplastics and their impacts on water quality and public health. So the University of Maryland Extension is in part funded by the USDA, and this is a reminder that we are open to all. So as far as discussion, there's a couple things that I'd like to share with you, a little bit about just the scope of the issue that we're facing, the various sources, what are the health risks, what's happening in our aquatic environment, how do microplastics impact our food chain, what are the issues associated with drinking water quality, what can we do individually in trying to reduce plastic pollution, but also how can we be better stewards to try to reduce the amount of plastic pollution in our environment. So you probably are aware that plastics are everywhere. Just look around you and think about how many items that we use day to day that are made of plastic. And there's different types of plastic, a lot of different chemistry, but we've heard about the oceanic island of plastic 1.5 times the size of Texas in the Pacific Ocean. But plastics are everywhere and much closer than we realize. We've also heard and seen, as this picture on the lower left shows, damage to wildlife due to plastics, but plastics are being ingested. It's in the air we breathe, the water we drink, it is everywhere. So, I mean, just thinking about the typical ideas of our plastic use, which is plastic bottles and plastic bags, we use a lot of these, okay? And if you just think about that, 10 billion plastic bags annually, okay? And how much we throw away, okay? We are a throwaway society. And that is having drastic implications on environmental and our own health. Plastics have been shown to be in our bodies because of the various exposures, which we'll talk about. Okay, so plastics are a huge group of compounds and different formulations. You can see that as far as the uses, packaging makes up the vast majority. We use plastics in building and construction, the automotive, electrical, just about anything that we do, it's plastic, as I said. Just look around you, right? And then there's different types of plastics, okay? We have the polypropylene, the polyethylene, we have the PVC, we have polystyrene, polyurethane. It is in so many different products, and these have different chemical characteristics, and that's why they're chosen to be in certain products. Some of these products, as you know, are recyclable. The unfortunate news about plastics and recycling is that only about 14% of plastics worldwide are recycled. Only 14%. So that means then 86% of the plastic we produce is out there. Now, some of this plastic obviously is in greater direct contact with the environment, our water, our air, plastic films, for example, okay? But interestingly, the sources of plastics, which will surprise you as you'll see later. All right, as far as the number 1 and 2 type of plastics, that's the polyethylene terephthalate, and then this high density polyethylene. Those are the ones that are most commonly recycled. So when we think about plastic particles, we've all heard the term microplastics, right? All right, well, think about this. We produce a product that's, let's just say it's a plastic bottle. Okay, a plastic bottle. We drink the water out of it. And then what do? Okay, maybe we'll recycle it. Okay, maybe we won't. If we don't recycle it, it's going to be thrown out off the side of the road or into the landfill, whatever. As as soon as it hits sunlight and soil particles, etc., and organisms, it starts to break down. So it starts as a mega plastic particle, and then it breaks down. And most of the research, the information that we have on plastic pollution is related to microplastics. It's just in recent years that we now know and the extent of microplastics being broken down further into nanoplastics. Now, nanoplastics are essentially the size of small bacteria and viruses, and then even nanoplastics dissolve and break down to where it is, again, dissolved plastic. So when we think about the exposure to the environment and exposure to us, again, we have these different sources and we have all these different types of activities that break down plastics. Photo degradation, that's light, essentially, okay? Then there's heat. Then there's reaction with water. There's decomposition by microorganisms, etc. So as these plastics break down, then they're, depending upon where they're located, they could be entering the soil, our water, our air. And then again, we're exposed to that directly. We could be inhaling microplastics. We could be drinking it. We could be eating it. And then there's the skin contact as well. What are the consequences? Well, there's many consequences with plastic pollution. And I suspect that we're only beginning to understand what the risks are to human health. But we certainly know that science has shown that there's gastrointestinal toxicity and issues, neurotoxicity, liver issues, reproductive issues, and then also disruption in our immune system. So major consequences. And the good news is that there's a lot of research going on and we're finding out more and more. So again, recapping the major sources that humans are ingestion of plastic particles through our food and our water, but then inhalation. But then there's also skin contact. And again, the nanoplastic particles in particular can easily be transmitted through the blood, through the gut, epithelial cells, into our lung tissue, etc., and then is distributed in our bodies. Plastics have been observed in lots of different types of body tissue fluids, as you can see here, again, both in infants and adults, found in blood, found in our brain, our kidney, our livers. Again, this is very extensive. And just because of the scope, the ubiquitous nature of nanoplastic pollution, we're being exposed to lots of different ways, and our bodies are taking this up. So if we look at our food chain, again, these things break down, it gets into the water. Seafoods can pick that up, plants can pick that up, and soils, microplastics are being absorbed by plants, taken into the fruit tissue or the leaf tissue. Again, the major ways of microplastic exposure is through our drinking water and our food sources. If we look at our oceans, we have that large floating concentration of plastics, as I said, approaching 2 times the size of Texas in the Pacific Ocean. But a recent paper shows that by far, at least in one study, showed in that particular area in the ocean, there were far more by weight nanoplastic particles than there were microplastic particles. So again, these plastics are breaking down, becoming smaller particles in our waters, which fish, shellfish, plants are taking up, passed on through the food chain, and passed on into our seafood. You can see some of the concentrations here. Again, depending upon the location, and then just some numbers here. Again, the number of particles, again, this is microplastic particles, not nanoplastic particles. If they were to actually evaluate nanoplastic particles, these numbers, I suspect, would be far greater. So again, interestingly, the number one source of plastic pollution to our waters is fabric, synthetic textiles. And if you think about that, by washing our clothes, nylon, rayon, polyester, when we're washing, we're breaking that down very slowly. And so that's getting into our waste stream. And then ultimately, through the wastewater treatment plant, it then goes to its release to surface waters. So therefore, our washing is actually creating a major source of microplastics. The second one is tires. And if you think about the, who knows, the bazillions of tires out there and the constant wear of tires. Tires have a little bit of rubber, but there is a significant amount of plastic in tires. And therefore, they're broken down and released into the environment. Rains wash it down into our streams, rivers, bay, and oceans. Okay, the other thing that happens with tires is that microplastic or nanoplastic dust creates an issue, and you can see the number 3 issue with plastic pollution is city dust. And again, that could be, tire wear and just, again, other plastics breaking down into very small particles, getting kicked up into the air with wind and traffic, and then we're inhaling that. And you can see other sources of plastics. But again, fabrics number 1, tires number 2, and city dust number 3. So the issue with contaminants, and this is true with plastic, is that we get this transfer into the food chain. So again, these smaller particles can be picked up even by algae. We have plant eaters that pick up those plastics, and then it's passed up through the food chain. And then again, we're consuming seafoods, and that causes an issue. The other thing that's interesting is that they're finding out that microplastics and nanoplastics can actually serve as a vector. A vector will allow the transfer of contaminants or pathogens. And so what happens is these particles get colonized by different organisms, and then also can pick up some heavy metals, for example, and other organic pollutants, and that can then be ingested by the animal, whatever the case may be. So finding out more and more about the potential for different types of issues associated with microplastics. Microplastics are produced, they break down, they get into our waterways, they get into our wastewater treatment, whatever the case may be, and that gets into our surface waters. That can also leach through the soil, enter our groundwater. Okay, if we look at the different types of resources around the world, this is talking about raw water, tap water, groundwater, and bottled water. You can see some numbers here. Again, these numbers are microplastics. So if we look at bottled water, where there have been a number of stories out there about bottled water, the numbers could range up to about 6,300 particles per liter of water. Okay, however, recent research has actually shown, with improved technology, has been able to measure up to 240,000 nanoplastic particles per bottled water. So again, by drinking bottled water, we're potentially taking in a significant amount of nano and microplastics. So when we look at drinking water systems, the different types of filtration steps that they go through can remediate some of the microplastics in the water. We don't know what the efficiency is as far as removing nanoplastics, but again, the type of treatments that we have are making a difference, as you can see here. When we look at specific types of processes, whether it be coagulation, sedimentation, sand, or carbon filtration, you can see that we're getting pretty significant microplastic remediation, essentially about 70 to 86%. Again, the important part to note, this is microplastics, not nanoplastics. We need to do more investigations to identify how effective our current treatment systems are for nanoplastics. So when we think about home water treatment, the good news is that there's several studies that have shown that some of the existing filters are effective. This includes granulated activated carbon, ion exchange, and reverse osmosis. Again, fairly high percent removal of larger particles. Again, these are microplastics. All right, these are not nanoplastics. The RO, or the reverse osmosis filter, has a very small membrane. So these are 0.2 micron pores. They perform best. And again, if the nanoparticles are 0.2 microns and larger, then they can be effective in filtering that out. Thing with any sort of home filter is that it needs to be maintained per the manufacturer recommendations. Just think about your car oil filter. If you don't change that, you're going to have problems. The same thing is true with water filters at home. You need to filter that out periodically. Otherwise, what can happen is the concentrations can build up so much so that you actually are releasing slugs or high concentration of the contaminant, and you don't want to do that. So what can we do? Well, there's been a lot of activity probably in the last 10 years, 15 years, looking at trying to reduce plastic use primarily, and this has really focused on plastic bags. Recall that plastic bags are actually not the most significant source of plastics to our waters. However, they are important. And so these efforts are very important to do. There has been bans on that. There's also countries that are looking at banning single-use plastics. So the basic ways to reduce plastics, obviously the most favored way would be prevention. Okay, this is obviously very difficult to do, not impossible, but very difficult to do. If you think about all the different things that use plastics, here in front of a computer and a keyboard that's probably 90% plastics at least. The good news is that some of these plastics are long-lived and hopefully could be recycled. Reusing item, for example, reusing your plastic spoon, reusing a bottle, whatever the case may be. Recycling, this is a huge issue. Recycling is another strategy to reduce plastics. Recall that we're only currently recycling 14% of plastics worldwide. Then there's recovery, and also disposal. So again, all of these things are important. What can we do to try to reduce the amount of plastic, either that we buy, but how do we handle it once we do buy it? The good news is that there's also a lot of research going on about plastic alternatives to show some promise with cellulose-based type of materials, that's plant-based materials, that they're more effective. So what can we do? If you think about it, with fabrics being the #1 source, can we rethink our wardrobes? I know this is a great challenge. And could we buy more natural fiber products in our clothes and our carpets, for example? What about building materials? What about food storage? Why not use glass, for example? So there's a lot of companies actually now that market plastic-free products, so I encourage you to check those out. Look for some of the more recent biodegradable plastic alternatives. As far as your washing machine, you can buy a filter at a box store that goes on the discharge hose of the washing machine, and that will help trap out the microplastic particles. Try to avoid these single-use or disposable products. Bring your own water from home. Bring your own bag, for example. Those two have been in practice for some time now. Consider using aluminum foil instead of plastic wrap. About 87% of aluminum that's produced is recycled. Again, that could be an alternative. Again, think about how you can reuse or recycle an item rather than just throwing it away and buying a new one. Can something be fixed, for example? And then get involved in your community. Find out what's going on with local legislation trying to reduce plastic use. So there's plenty of information out there on microplastics. Again, fortunately, there's a lot of research going on studying the issue of micro and nanoplastics and impacts to both our environment and health. So I encourage you to take advantage of these resources. Thank you.